Hello, everyone. We're moving on to our last talk of the afternoon and continuing the theme of approaches to address problems caused by the social insects. We now have a talk from Rudy Plarre on screening of two plant-derived extracts from Sri Lanka for their potential to control the subterranean termite Coptotermes formosanus. Over to you, Rudy. Thank you.
Well, thanks. Hi, everybody. Good afternoon. We, that is Dr. Udaya Cabral from Sri Lanka, Pascal Querner from Austria, and myself from Berlin, Germany, have tested two plant extracts for their potential to control termites. And this is the story. As you all know, Sri Lanka is an island in the Pacific Ocean, southeast of India, and it's well known, first of all, for its tremendous and extraordinary wildlife, but also for its extreme history, very fascinating history. And almost all written records from Sri Lanka are stored in the National Library of Sri Lanka, which is located in Colombo. This library holds all the main collections that usually the ordinary library holds, like main collections, newspapers, periodicals, and so on. But they also carry on or have a large collection of ola leaf manuscripts, which is the traditional writing in Sri Lanka and also in India, also known as palm leaf booklets or palm leaf writings, where the ancient knowledge has been transported. The main problems that Sri Lankan libraries face with insects are the usual insects that we encounter all around the world, like the silverfish, like book lice, like tobacco beetle, and cockroaches. However, there are some specifics to Sri Lanka as well, and this is the Indian bookworm, Gastralus indicus, and termites, of course. And mostly important in Southeast Asia is the subterranean formosan termite Coptotermes formosanus. I had the chance to visit the Central Library in Colombo in 2016, that was. And here I met Dr. Udaya Cabral the first time, who was the assistant director on conservation. You also see two of the main staff members at that time. Well, they showed me their goods, their treasures, and one is the first book printed in Sri Lanka that was printed in 1738, and a huge collection on palm leaf manuscripts, which is really impressive. However, as I mentioned, the Indian bookworm and termites do feed up on these books, as you can see here. And unfortunately, they also feed on the palm leaf manuscripts, which is a tremendous loss of knowledge and cultural heritage if nothing is taken care about those pests. However, not all manuscripts are destroyed. Some of them, over hundreds of years old, are preserved in such a good condition that you don't see any infestation of at all. And this is due to some natural compounds that were used in ancient times to conserve these palm leaf manuscripts. One is called dumala. It's the resin extract of Vaterina copalifera, which is brownish to black in color. And as I said, it's derived from the tree's resin. The other one is called Neem. It's light yellow in color, and it's derived from the seed oil. The scientific name is Matuga longifolia. Well, in 2018, Dr. Cabral visited Berlin and our laboratory, since we do rear termites from around the world. This is one of our typical rearing tanks where we breed Coptotermes formosanus. Besides that, we have over 20 species or strains of termites from around the world. I like to call it the biggest termite zoo in the world, and if you're interested, please see our webpage for more details. Coptotermes formosanus was originally picked up in 1972 from a founder colony originated from Louisiana, USA, and since then reared at our laboratory. So it's a culture that's over 40 years still running. Well, Dr. Cabral brought the two oils, Dumana oil and Neem oil, with him, and we just started out with basic repellent tests. As you have seen previously, by Angelique, who was talking about drywood termites. We very similar set up repellents tests where half of the petri dish is treated with the oil extract and the other half of the petri dish is untreated. We tested 30 workers per replicate, 10 replicates per treatment, plus 2 untreated controls, which you see on the right-hand bottom. And you can also the picture is obvious that we do see a strong repellent effect on the treated side, and in the untreated control, both sides are pretty much taken up evenly by the termites. The same situation occurred with the neem oil and with the Neem oil. Here you can see the yellow color, as I was pointing out earlier. And again, we have a strong repellent effect by the treated area and an even distribution in the untreated situation. To sum up our experiments, we have calculated a repellent index for consecutive 3 days after 24 hours, 48 hours, and 120 hours. We also did 2 kinds of preconditioning after treatment. We had some natural aging over a week in an open petri dish before we started the biotest. And we also inserted our treated filter paper into the wind tunnel with an airspeed of 1 meters per second at 40 degrees Celsius. Some kind of speeding up the aging, which we call artificial aging. Well, we don't know exactly what that would be in real time, but it's definitely an accelerated aging. The second variation of the experiment was that we exposed the termites in a petri dish with a closed lid. So we condensed the evaporation and compared that with the behavior in an open petri dish. Just a few things that you can see here. The repellent index declined over experimental time. So from 24, 48, and 120 hours. You can see, for example, here in the top row, from almost 100%, it declined to 90% for the Dumala oil. This also was true for the Neem oil. The other decline in repellent index was observed when you compare natural aging over artificial aging. Again, natural aging caused higher repellent index, and the repellent effect was lost after artificial aging. This is true for Dumala, and it's also true for the Neem oil. Thirdly, the repellent index declined whether we ran the experiment in a closed dish or in an open dish. Again, just to show you the data, compared for Dumala from almost 100 in the closed dish to 92% in the open dish. Or with the Neem, very similar, from 90 to 88%. So overall, when you take all these 3 different setups, we have an overall decrease in efficiency depending on whether we run an open dish experiment or a closed dish experiment, whether we had natural aging or artificial aging, and the longer the experiment ran, the less repellent effect we were seeing. So ideally, we had almost 100% repellent index, and the worst was around 67 or 65% of repellent index.
You've got about 5 minutes, Rudy.
Yes. Well, overall, the subterranean termite is different from drywood termite, and it buries into the soil. So we tested how would termites behave when they are in the presence of treated material. This, well, I'm running through this just because it's not so important now. When you take a look from below, you see that the termites in the untreated control have dug their tunnels throughout here. Okay, so 5 replicates. In the presence of Dumala oil in the natural aging, we had a strong effect on the termites. They were unable to tunnel. But in the artificial aging, when the product has evaporated, we do see termites being able to tunnel and not being so affected by the presence of the oil. Our third experiment was creating a barrier treatment. So again, we had an arena, which I will simply show up here. We had 250 termites being exposed to an arena, and in order to get to the wood, which was offered as a nutritional source, they had to cross this barrier. And again, from a picture below, we see that the termites dig into the ground, but then they stop when they approach the treated area. Compare that to the untreated control, termites immediately cross that barrier and also from underneath attack the wood quite soon. So in conclusion, let me point out the pros. Dumala and me show promising effects, with Dumala being better than me. Acting as volatiles, termite can be repelled and thus kept from attacking artifacts or entering buildings. And high concentration volatiles act as plant fumigants and even have toxic effects. And most important, it is a local production that is economically possible and would be ecological sustainable. However, we do have some cons. Dumala and me have a very strong odor and possibly stain-treated objects, so maybe you don't want to treat your artifacts as creating barriers. As natural products, standardized quality is challenging, and non-target effects among insects are likely and can't be ruled out. And that's the most important thing, we have no data on human safety regarding when you deal with these products. Intermediate conclusion is volatile reduces effectiveness over time, which can be good or bad depending on what you're aiming for. Well, this concludes my presentation, and I thank you for listening, and I'll now turn around and go back to work. Thanks for listening.
Thanks, Rudy. I hope you'll be able to spare us some time to join us in the Q&A shortly. Okay, thank you. And that's the end of this broadcast. Thank you very much.